Okay, we want to take a look again at 8.4a. Actually, this is an introduction to 8.4a, where we want to generate a different representation of data given another representation of data. And we want to take this data and use 8.5a and predict and find possible solutions. So these are just actually the teaks that you are the standards that go with this lesson. You don't have to put those lessons in your notes, put those standards in your notes. We are solving equation using addition or subtraction. Some vocabularies that you'd have to know is what is an equivalent equation and inverse operation. Okay, so we will definitely put those definitions up for you. Now, if you have a scale and you're looking at that particular scale, and you're taking a look at that particular scale, and you want to definitely make sure that that scale stays balanced, you have to make sure whatever's on the left side must be on the right side. And we can show this by saying if we have, for instance, x plus 3, and we want that to be equal, the only thing we can do is, well, let's say x plus 3 is equal to 5. That'll give us an equation. If in order for it to be equal, whatever we do here, we must do here. So we can take 3 and subtract 3 from both sides, and that'll give us x is equal to 2. So that means x plus 3 and x plus 2, x plus 3 is equal to 5, plus 3 is equal to 5 is the same, or is an equivalent equation to x is equal to 2. So that's what we're pretty much saying when we're talking about those particular equations to determine whether they're equivalent or not. It also says you can solve an equation by using the inverse operation. So what are we talking about? So you want to undo. So if I have 2x, in order for me to undo 2x, I must not multiply, but I must divide and make that x over 2. All right. So we're not going to get into multiplication and division yet, but we do want to definitely take a look at adding and subtraction. So let's go ahead and take a look at a particular problem. And we'll just do maybe one example, and then we'll go ahead and record it, and then I'll do another example with another class to keep you guys from being so tense. I think that's fair. Okay, so let's go ahead and take a look at one example. So example 1. And I want to solve an equation using subtraction. So I have the equation 8 plus x is equal to a negative 15. So this is my given. This is given to me. This is given. This is my original equation. I didn't find it. I mean, I didn't work it. It actually was listed. So anytime you see a problem on the board, that is given. So your job is to work the problem from there. So in order for me to get x by itself, or to make this equation equal, I must do the opposite to what's happening to x. So this is 8 plus x, so I must subtract 8. And I must subtract 8 from both sides. Okay? So once I do that, that's going to give me x, because a positive 8 and a negative 8 gives me 0. We don't have to write the 0 because it has no value. And that's going to be x is equal to, but look at the other side. You have a negative 8 and a negative 15 that's being added. So what do we do here? We add, according to the rules of integers, the absolute values. 8 plus 15. And what is that going to give us?
Negative 23.
It's going to give us 23, and the sign is negative. So again, the given, and then here you do the opposite, the inverse of what's happening to x, and it's being added. So you do the inverse, and the inverse say subtract, and once you subtract one side, you must subtract the other side to keep the equation balanced, and then here you simplifying x. Okay, it is just that simple. All right, so let's go ahead and work